All right, welcome everyone to the January 2022 FMDiSC. I'm still finding it hard to say 2022. I feel like I'm saying it's the year 2200 or something. We have some great presentations today for you. We've got Kevin Frank and Steve Senft-Herrera. I hope I'm not butchering your name too badly there, Steve. Oh, awesome. Thumbs up. And they'll be talking about JSON Query. And then a little later, we've got Corn Walker from Proof+Geist talking about data modeling. And I think they're both going to be great presentations. Really looking forward to both of these. So we're going to jump in just a second here. I just want to ask that everybody make sure you're muted during the presentation. That way we don't get background noise that's distracting and so forth. Obviously, if you want to ask a question and need to jump in, then you can hold down your space bar and do that. But it'll be a big help for everybody to make sure they're muted right out of the gate. All right. So with that, I'm going to turn things over to Kevin Frank, who's going to kick things off.
Hi, Kevin.
Hey. Well, thanks for having me. How exciting. Hi, Lynn. A long time no see. Can you, am I sharing my, let's share. Hey, I've got a great idea. Let me share my screen. Is everyone seeing that?
Yep.
Looks good?
Yes.
Okay, thank you. Hi, I'm Kevin Frank, and I'm really excited about presenting with Steve Senft-Herrera on JSON Query. And we do have a resource page for this presentation, filemakerhacks.com/tag/JSONQuery. A little bit about me. As you know, I'm Kevin Frank, 30 years plus FileMaker experience. I'm the technical lead on Codence's Genesis Transactions product. I have a blog, filemakerhacks.com. And as I said, we have a resource page for this presentation. So what is JSON Query? Custom function which operates on JSON. And it's authored by Steve Senft-Herrera. Typically, you point it at an array of objects or an array of arrays. And it returns child elements matching your query parameters. So as an example, here's a typical two-dimensional JSON array. So we can easily extract the row. FileMaker gives us a native function, JSON get element, to get the row. But they don't give us any corresponding function to target a column. And now I'm done showing slides and I'm going to go into some demos. So let's, so here's that array. And if I wanted to get the column, and let's say the fifth column, which of course, since JSON uses zero-based indexing, will be column number 4. So what I could do is, and I'm not going to get into what's exactly going on here because Steve's going to talk in depth about that, but I just want to give a little sense of what can be accomplished with JSON Query. So, but what you'll notice right here is I've extracted the column and I've turned it into an array. Now, maybe I don't want it as an array. Maybe I want it as a list. Or maybe I'd like to get the minimum value or the maximum value or the average. Maybe I'd like to move on to the next example. Yeah. So actually, I'm going to give a little tour of the JSON Query demo file, but I'm also going to talk just for a minute about sort of the backstory here. So what happened is when JSON was introduced in FileMaker, I started wishing I could query JSON in a SQL-like manner. And Steve had released on, I believe, one of the online forums, a JSON Query version 1 back in 2018. Well, I was lucky enough to download it 4 years ago because then it disappeared and I couldn't find it. So I had this demo and it looked promising, but there were some things I wished it could do, it couldn't do. So I reached out to Steve about 6 months ago and said, hey, I'd like to talk to you about this on FileMaker Hacks. And maybe, and I was thinking to myself, maybe if I get lucky, he's added a few improvements. Well, that was the understatement of the century. So we interviewed him twice on FileMaker Hacks, and as they say, the rest is history. So I'm just going to give a real quick tour of the demo file, and I'll also point out that that's available on the resource page right here. So let's come back to that. So in the demo file, you've got sort of a general about screen. You've got a reference sheet, which is quite extensive, but it's also just mostly an overview, but it just gives you an idea of some of the things you can do with it. Where things get really exciting is here on the examples. And what we have here is a portal, and this is the filter for the portal. And so you can choose either show all or go down into a specific area. And then let's take a look at, if you click the row, it then takes you to this detail page for this example. And what we can see here is we have a JSON input. I'm going to start with these. There's 4 panels here. I'll start at the top right. And you can choose the amount of JSON you want to put in there. And then over here, we have just a general explanation for the example. And JSON query takes 6 operators, and they're sort of listed here. And then down here, the explanation, just some human-friendly notes about what's going on. And over here's the result. And the way you get the result is you click Run Example. So we just asked the question, can we see in this JSON here, look at, there's 250 records, go into the email for each of those and find anything that ends with .net. So what's come back is the JSON elements that match, the JSON entries that match. But maybe we don't want to see the whole thing. Maybe we'd just like to just get those email addresses. So I'll point out this will clear the example. I don't need to clear it before I run again, but we click Run Example. And now we've got back the .nets, the email addresses that end with .net. So I come over here. I'm going to just go to the very next example. Oh, and by the way, I could have just navigated this way through the examples too. And I want to point out that another thing we can do is it contains. And the place where I'm going to use contains is I'm going to show, this is a file that I'm also going to make available, and it's called the JSON Query Sandbox. Okay. And what we want to look at here is the example actually from the FileMaker Data API. So if you've used, as you know, the Data API recently got a new script step called Execute FileMaker Data API, which is really neat. So it doesn't use your API quota or anything like that. This is just a script step that you can run in FileMaker. This is a demo file from my Thinking About JSON Part 2 article, which is also listed on the resource page. And so here we have almost 600 invoices. And if we throw Execute FileMaker Data API at this, it's going to return this JSON here. And so let's say somebody says, hey, I want to get, for people in Alabama, right? And I'll point out, I don't really have a state field, but I do have the address here, their quote mail label, because that came back from the Data API. And I want to know what wines the people in Alabama are drinking. And so if I throw this into the data viewer, let's see, where did my data viewer go? There it is. Right. I've got an example here, and it's eventually going to open up on the screen. And so I will point out the first thing I'm going to do is I'm going to reach in and grab just the portion of the JSON I care about. So that's what this let is doing. So I'm assigning that to ~JSON, right? So I'm looking at the node in there that has the stuff we care about, the actual data, the response we got back, okay? So I'm going to say, hey, look at the mail label and find anything that contains space AL space. Okay, so I'm sort of assuming that's good enough to get me Alabama. And at the moment, you'll see on my result path, I've now brought back the JSON nodes that match. But what I actually want is, I'm going to go over to example number 2. What I actually want is those wines. And so I now provided the path to what I want back. So rather than returning all the JSON, I've targeted what I want back. Then maybe I don't want it in an array. And if I don't want it in an array, let's see if I can do this. I could instead throw the list function at that here inside this argument. Well, actually, I'm saying it's the list function, but it's the list operator for JSON query. And now I've got this, and I've even sorted it. But one of the things we can see is we've got some duplicates. Some people, multiple customers in Alabama ordered that wine. So maybe instead, what I want, oh, and I'll point out too, right, that JSON query is a tool, but we can still wrap a regular FileMaker function around it. So I've put sort values on here so I can get these alphabetized. And then the final thing I want to do here is say distinct. And now I've removed the duplicates from the list. And I'm going to show just one more thing, and that's my country data here. So let's actually see if I can get those out of there. No, I won't waste time on that. Actually, will I waste time on that? No. Yes. Okay, so we're going to look at this country data. And here in this demo, by the way, I tell you where I got the data from. And so here's our country data. And this has a listing for all the countries in the world. And it has lots of information about each country because I told it, give me everything. And so one of the things that's interesting is if countries get a 3-digit alpha code, and for each country that's listed, they tell us all the bordering countries. So I was wondering if I could use JSON query to make a list of all the countries bordering Russia. So let's see, and by the way, the name, as I found out in here, the official name of Russia, at least in the English language, is Russian Federation. So what I did was I threw this together and I put this little let together and just sort of built it up A, B, C, D, E. So when I do A, I'm getting back everything, okay? And if I do B, now I've got just the entry for Russia, the Russian Federation, and we can see the 3-digit codes of all the countries that border it, all right? And then if I come down here to C, now I've isolated that list of the bordering countries. And if I go to D, now I've got them in a list. And now I'm going to do a second invocation of JSON query with that information using what's called the in operator. And I'm going to say, hey, find me anybody whose alpha code is in this list here. And that's what we get back. So I proudly showed this to Steve, and he said, that looks great. He goes, would you like to hear a slightly more efficient way to do that? I said, of course. And he said, okay, you can instead do it like this, which is just quite simply, you can actually, it turns out you can embed the list logic into the first call to JSON query. So we're still doing the same work, but we're just doing it in fewer steps. If I do B, just short-circuited some of that work, and then the second call does that. So that just gives a little flavor of some of the things you can do with JSON query. And it's really an honor and a privilege now to pass things over to Steve Senft-Herrera.
Hey, Kevin, thank you. Let's go ahead and share my screen and get started. And yeah, I enjoyed it. I thought that was a really, some cool examples. I hadn't seen all of those, and I like them a lot. Alrighty, so the usual preamble, a little bit about me, been a FileMaker developer for a long time. I think it's close to 30 years, but I put 25 plus just to keep myself honest in case I'm off by a little bit. Started with version 2. Some of my initial inspirations in the 90s were JMO, John Mark Osborne, and Matt Petrowski when they came and did an amazing presentation at our local BMUG. Some folks may know me on the various forums and whatnot as Steve SSH. This is pretty much speaks for itself. This is what I do and what I've done. FileMaker work from starting as a hobbyist to working with Beezwax DataTools since 2015, and love it there. Got a lot of friends there, and the amount of talent and ability there always keeps me feeling pretty inspired and also pretty humble pretty much every day. Before we get started, I did want to make a couple special thanks. One is to Kyle Williams, a FileMaker community member who's done a lot to promote JSONQuery and give me feedback on it. Kevin, of course, who's done more than an awful lot to help promote this particular project. Without Kevin, this wouldn't be here today. The function wouldn't be in its current state. He's shared a lot of his time, wisdom, input, feedback, and friendship, and I really appreciate it, Kevin. Thank you. My pals at the Beezwax team, what can I say? You're amazing, and I love working with you. And everybody else, and you folks for having me here. Moving on to slide 2, let's talk about my agenda a little bit. My agenda is not to sell you on this function and make you think that you've got to have it or that it's a must-have for everybody's toolkit. My agenda is to show you what it does, stimulate some interest and curiosity, answer any questions, and basically, for those people who do choose to try it out and or use it, I want you to have a great experience with it. And so that's where my focus goes, is to sort of keeping up the function and documentation in a good shape where you can have a good time with it if you do choose to use it. And so having said all that, let's get started. I don't present much, so let me know, feel free to interject if I'm moving too quickly, or if I'm hanging on too long on a topic, I'll be happy to take that and adjust accordingly. I would like to invite everybody to interject with questions as you have them. I think interrupting and going on a little tangent or pursuing a question is a worthwhile thing to do in this particular presentation. No need to save them till the end, but I'll try to save a little time at the end for some questions just in case. And so let's get started. Get this out of the way. And we'll go to the file that you've just seen Kevin show you. You saw the list of examples. This is all of them right now, and there's quite a few. I tell Kevin and I both have musical backgrounds, so a lot of times we'll use musical analogies, and I've said to him a couple times that these examples are kind of like musical etudes that are not that pretty to listen to, but they're really helpful for developing your skill. So, they're a little bit dry, but if you make your way through all of them, you'll learn a lot about how the function works and what you can do with it. But not wanting to have that kind of material for today, I made a special set of examples for this presentation. So if you go to FMDiSC presentation, you'll get to these particular examples. And these are the ones that I want to take you through today. So having said that, let's take a look at the first. Slightly different arrangement from the screen that you saw Kevin show you just a little while ago. I redid this last night so that we could have sort of make use of a larger screen for this presentation. You can see a little bit more. So for starters, we're going to be looking at basically two sets of JSON, and I'll digress from this for just a minute to show them to you. One is a set of JSON that's Nobel Awards, and the full JSON looks something like this. And an individual item from that JSON looks something like this. So you can see each element in the array, the full set is just basically an array of all these kinds of JSON elements, contains the Nobel category, the people who won the award, some information about those, the names of the people and the reason that they were awarded that particular award. This is bogus data here just for the purpose of allowing me to demonstrate some features. I put in something that's like, how many average times is this particular award mentioned on Twitter? Who knows if they ever are, but I needed something to demonstrate searching on numbers and so forth. So I threw that in there myself. It's not real data. So that's one set of data that we'll be looking at. We'll start with that, and a little later on, we'll move on to some country JSON that you just saw Kevin working with. And I just wanted to give you sort of a quick look at what an individual JSON object from that country JSON looks like. I've stripped it down a little bit from what it was in the source, again, just for the purposes of having a demonstration and not, overstimulating all of our senses with like super complex JSON. I just pulled out some of the stuff that I thought we'd be able to have some fun with working with. Okay, so let's have a look. Let's start with something that's not JSON query. You can see this is the calculation that I want to focus in on this middle pane right here. And it's an example of using iteration to scan through some JSON in order to pull out a value that you're looking for. Now, when JSON query first came out, we were at version 16. We didn't have the while loop, but this is the sort of thing that we might have done with the scripted loop. Basically, you start with your JSON, you figure out how many keys you've got in it, and you iterate through, and for each iteration, you perform a test to see whether or not you've matched the particular category that you want to match. And if so, you append that to your result buffer, and otherwise you keep your buffer the same. And at the end, you return it all as JSON. You take a little bit of care to make sure the commas are in the right places, and you're good to go. So this is the sort of thing that you might find yourself doing if you have to scan through JSON to find a particular match. In this case, we're scanning through all of the Nobel Awards to look to see who might have won a Nobel Award for FileMaker Pro work. So let's have a look and see what we get. Turns out Bruce Robertson won the Nobel Award for FileMaker Pro development in the year 2000. And yes, I did doctor up that data. You can see here, it didn't take long to do that. We've got 250 records that we're working on, or I should say 250 elements in the JSON array that's our source. And it took under 1/10 of a second. So pretty nice performance there. Let's boost this up to a larger size of records, 659 records, run it again. And we can see the overhead increase to just over 1/2 second. Now let's double the amount of JSON. We're up to 1,300 records, run it again. I got a little bit of a beach ball on this side, and it took 2¼ seconds. Last example, quadruple the set, 2,600 records, and we run it. And I think this one on my home machine takes about 14 seconds. My home machine is kind of slow. I'm hoping this one will finish in just a few seconds. There we go. 9 seconds of time to scan through all this JSON. So this was actually the first inspiration for writing this particular function, JSON query. The inspiration was I wanted a faster way to do this. I don't know if you're here, Jared. I think I saw your name on the call, but Jared's one of my buddies at Beezwax, and he's an absolute genius. And he came up with a brilliant way to solve this sort of situation on a one-off case. And we talked about it some, and it eventually wound up being the inspiration for this particular function. So I have Jared to thank for that. Let's take a look at what the function would do. With the basic call with JSON query, you're supplying the JSON. You're saying, hey, I want to match the category property. I'm using an equals operator, which is saying that in order for something to match the category that I supply, which is the next parameter, FileMaker Pro, has to be equal to whatever I pull out at the target path. JSON string is your way of sort of giving JSON query like a hint as to what it's looking for. You're telling it the data type of the particular node that you're targeting. And for now, we're going to leave this last parameter empty, and that just means it's going to return the entire matching object. So let's take a look at how this performs in comparison to using the while loop. So we run it. Again, with 250 records, pretty much anything is fast. So we've got something very acceptable. We continue to go up to 659 records, and we're still under 1/10 of a second. Now we get to the double set, which I think took about 3 seconds in the other example with the while. We're still, well, we're basically under 1/4 of a second at this point. And let's go up to the full size, the one that took about 8 or 9 seconds with the while. Only takes us, well, just over 1/4 of a second. So that was the first inspiration, was JSON query was built with the idea of like, we want to be able to do this kind of matching and searching and filtering very quickly. And that was basically the impetus for writing it. Once it was written, we started adding more features to it. But that was basically its start. So I think of it as like the workhorse for finding a needle in a haystack. If your JSON is very large, it can still perform very well as long as the result set is going to be small. That is to say, as long as it's only looking for a few matches in there, and in other words, that needle inside of the haystack is going to perform well, at least for the equals operator and a few other operators. There are some other features that I added since then that basically they perform at about the same speed as the while iteration would. There's no performance advantage in those cases. So this is just another example of searching for something. We're going to take a look for at the particular node in our country's JSON that has our supplied ISO or our supplied alpha code, and we're going to return that particular entity. Again, really fast. We are working with a pretty humble size of JSON. There's only 250 records here, so pretty much most of these demonstrations should be fast. But you can see there's also a convenience factor. You know, you're basically, you no longer have to write that loop. You basically just specify, here's the target path, here's what I'm looking for. Now give me what I want to get back. All right. Moving on. The result path, that's this last parameter right here. And that's what allows you to return just an individual property. So if I were to take this example and remove that string name that was just there a moment ago, and I run it, I get the entire matching element of JSON there. And in fact, it's returned in an array because there could be multiple matches, in which case you get an array of matches. So I'm going to put in here the string name, which is basically a property from the source JSON. It's in every element. And when I put that in there, it tells JSON query, hey, just give me the value that you find at that property for the matches. So it's a way of basically just getting a single property instead of the whole object. Any questions so far? Okay. Moving on, we're going to check out another operator. You saw this in one of Kevin's demonstrations, which is the in operator. Gives you the possibility of matching against more than one value for a particular node. So in this case, I'm targeting, and you'll notice here, I've chosen to target a node that involves an array index as well, just sort of taking the complexity up by one small notch. So let's have a look. It's in here somewhere. There it is right there. Top level domain, for whatever reason, is being stored as an array inside of each of these JSON elements. So we're going to target that by specifying the path to it. We'll use the in operator, and that's basically telling JSON query, hey, consider it a match if the value at this particular node matches any of these values that I give you, and I'm giving them to you in a return delimited list. Hence, this is just a regular use of the list function from FileMaker. And again, return me just the name. And we get our results. Okay. Moving on to another operator. Kevin also made use of this one when he was searching for the wines in Alabama. It's the contains operator. It basically allows for sort of pattern matching. And in this particular example, we're basically saying, hey, find me all countries which have the string republic in it. Let's go ahead and run it. And we get our list of values there. There is a case sensitive version of it. If I were to say contains case sensitive, I'd probably still get the same values because chances are the case is correct. Let's try it again. But then if I were to do something like this, keep the spelling the same but change the case, we'd find that none of them would match. So you've got a case sensitive version of matching if you want it. Similar operators to contains. There's also a begins with and an ends with. So let's just try those out for a moment here.
It's 1:30.
It's 1:30. Okay. Begins with, let's say we want to begin with just the letter W. So let's see what we get. What country names begin with the letter W? we have those. We have ends with. Let's see if anything ends with W. Apparently not. Let's try something easier. There we go. All right, so basic pattern matching was added to JSON query because once this sort of got underway, that is to say, once the development of this function got underway, I kept asking myself, what more features could we add to this that I would want to have that might be useful when I'm matching things within JSON? And the features just kept coming and coming as ideas, and I kept adding them in. So moving on to things like matching on numbers, we have the ability to do inequality matching. You've got the basic operators down here that you would think of: greater than, less than or equal to, greater than or equal to. And we're able to match on those as numbers, and it's pretty much what you would expect. In this case here, I'm looking at a bogus field that I added called UFO sightings, which I just populated with random data saying that these were like annual UFO sightings on average or something like that. So in this case, we're going to find all countries that have a UFO sightings value, which is less than or equal to 100, and we're going to return the name of those countries. And there they are. Not much to say about that. It's pretty much exactly what you'd expect. You're doing a numeric comparison, and it's a less than or equals to comparison. In this case, I won't bother you with going through the other examples. It's exactly what you would expect when you do greater than, equal to, etc. There is, however, another variation on inequalities, which is a range operator. A range operator does what you would think. It allows you to select or match based on numbers which fall within a specified range. So instead of just having one endpoint where you say everything greater than or everything less than, you can give two endpoints and say, give me everything in between. So in this case, we're finding all countries that have a UFO sightings value, which falls between the two values of 100 and 120. Basically, the way that you supply the two range values is exactly like this. You supply them as a return delimited list. Let's go ahead and find those countries there. We've got those countries. There are a few different variations to this. The variations are that you can add an X to one or both sides of these three dots, and that will tell JSON query that you want to exclude the endpoint. So when you're just using the three dots, it behaves a lot like FileMaker, and we can thank Kevin for that. I had this wrong, and he said, hey, Steve, you need to make this so that it's intuitive for FileMaker users, and therefore the behavior of your three dot operator should really match what FileMaker does by default. And he's absolutely right, of course. So after fixing it up, basically the behavior is that the three dots gets you a range with endpoints included. And when you want to exclude an endpoint, you basically put an X on that side, and that'll exclude the endpoint. I'm not necessarily thinking that that'll change our results here because these probably fall within the results. Yeah. So nothing that we can demonstrate here without going to some trouble, but at least you can see what the syntax of that is like. And I should mention also, a lot of these examples that we're sort of flying through right now, if you get interested in them and you want to dig in further, you can go back to that long example list that I showed you at the top, the one that I described as sort of etudes that aren't that interesting. You get all the details on all of these things and how they work. There are a few features that I'm showing you today that are in an upcoming version of this function that'll probably be released within a couple of weeks or so. But by and large, everything you're seeing here is in the original version that's already on Kevin's site. And yeah, and the documentation is in those examples. So what I wanted to move on to next is customizing the output. And the reason why I want to do that is because as I was writing these examples, or as I was doing this kind of work, you see a lot of these where I'm just returning just the name of the country. And that's kind of cool, right? You can get the name of the country, but I'm thinking, many times we want more than just one property. And so that result path parameter, the last parameter where I was specifying name to return the country name, is somewhat limiting in that it only gives you one option of one thing to return. And so with that was born the concept of an output transformation. Output transformation is a replacement. You put it in the same place that you would have put in the name. So in fact, let's just cut it out for a second, put name in here and take a look at this sort of, I guess it's the same query we did a minute ago, right? UFO sightings between 100 and 120. When I put in this map here, this output transformation, I'm able to get multiple fields from each matched object. And I'll just go ahead and show you what it looks like right now. So in this case, instead of just returning the name of the country, I was able to pick and choose the fields that I wanted to return from the JSON for the matched objects and have them be included in the output. And moreover, I was able to include them using the key values that I happen to choose. So like I happen to choose country to output this, but if I put country AAAA, something like that, we'll see in the output, it'll use the value that I said to use for the output key. So it's a powerful way to take the matches that you're getting and really customize the sorts of results that you want to have, so that you aren't restricted to just returning one particular property or the whole thing, because those were kind of two extremes. You either get everything or just one small amount. And this was basically the mechanism for allowing an in-between and the ability to customize the output that you want. Now I'll mention about this what I sometimes refer to as a map, what I try to refer to more technically as a transformation. It is JSON. Right now you can see that the JSON is not really well formed, right? I'm using single quotes for the JSON. It actually expects, and I put this in the comments here, you can't see right here, but I'm going to copy it. It actually expects a well-formed JSON object. I'm going to pop in a well-formed JSON object, the same thing. So if I run this right now, and this is JSON that's been properly escaped with all of the correct quotations, it's going to work just fine. That's exactly how it was designed to work. And that's how the current version of the function works. With the upcoming version of the function that'll be available in a couple of weeks, I made the ability to have the input be tolerated using single quotes, and actually for the key values that are known, you don't have to have any quotes at all, just as a shorthand so that it would be easier to read and easier to write. If you're a JSON purist and you don't want to use a shorthand, you can always go and use perfectly well-formed and properly quoted JSON. That'll work just fine. That was actually the way it originally worked. But I like this version here where I can sort of dash out some JSON and just use this sort of shorthand notation in order to have my calculation look cleaner within FileMaker. Any questions about the transformations? We're good? Okay, let's see how we're doing on time. We're getting close to the point where I said I should be through with the basics, and I think we're getting close. All right. Yeah.
Can I jump in with a quick question?
Please do. Yes.
It's brilliant, Steve, and I saw this quite a long time ago, and I was impressed then. Yeah, quick question. The transformations, just interested in types. Can you like change types, or do you have to be careful about types? You know what I mean? The JSON.
Yeah, types. Yeah. I think we'll have some examples coming up in later on that illustrate a little bit more about what you can do with data type. But you'll notice right here, I've got data type, and I've specified, this is going to be a number type. And so when it appears in the output, it appears as a number. If I hadn't put that line in there, it would default to string, and you'll have a quoted output value. If I had chosen, let's just riff on this for a minute. Let's find something in here that's an array. Borders is an array. So let's, instead of choosing UFO sightings as a source, let's choose borders. And we'll give it a tag, a property name that's appropriate. And in this case, I definitely have to tell JSON query, hey, this is an array. And once I tell it that, I will break my JSON because I didn't put a comma there. Okay, let's try that again. Once I tell it that, it knows that borders is an array and it will treat it properly. So basically, you have to furnish the knowledge about the structure of your JSON and what you're expecting to get. And then you have to, if it's not a JSON string and you know that you're going to need to handle it, especially because it's an object or it's an array, then you definitely have to provide this data type parameter in your map. But once you do so, JSON query will be able to handle it just fine. Does that answer the question?
Yeah, it does. My phone's ringing and I can't find it.
Oh, okay.
Thank you.
All right, yeah, absolutely. And I'm glad you asked. It breaks up some of the monotony of me just talking, so it's great. I encourage more of that. All right, so moving on. Another common use case that I thought, and again, remember, this is my mindset. I wrote this function originally just to sort of scan and search JSON quickly, and then I started piling on the features based on what I thought I would want to do and what I thought my friends in the FileMaker community would want to do. And a use case that really stood out is, I think a lot of times we have an array like this, and we want to harvest just one particular property out of all of the elements, from each element. So it's kind of like,
yeah, I think that what we're moving is way too small to get moving line involved. We actually have rented a small cube from U-Haul.
I think somebody's like not on mute, and maybe it could be. Thanks. Sorry.
Thank you.
Yeah, no worries. Let's see. Yeah, harvest an individual property from all of the JSON elements. So instead of matching and saying, okay, I'm just going to find one particular element and return me something, we're basically saying, hey, let's do away with the matching. I want everything. That's what the match all operator does. And in this case, we're saying, I want the subregion out of all of these. So subregion is something like you'd expect. Like we've got Southern Asia. I'm sure we've got Eastern Europe. We've got who knows what else. Let's find out. There they are. So it basically scans through every element and return just this property from every element. And I'm going to peek ahead and see what the next example is. Yeah, okay. The next example is exactly what I wanted to show. So basically match all is your way of basically grabbing any one property and outputting it. It could have been the name of the country. We could have done that to get a list of all the names of the countries. Could have been the Alpha 3 code. You get the idea. Let's move to the next example. We had done subregion in the previous example, and you might have noticed, let's just run it again real quick. There are going to be some duplicates in here, right? Because these are not unique to one particular country. So if we want to make that list include just distinct values, we use an operator here called distinct. This is very similar to something that Kevin showed, although it is a separate operator. I'm going to avoid the obvious pun here. It's another operator. We'll just say that it's another operator that allows you to take that output and return it as a distinct list. Without it, you have subregions with repetition. And then again, with it, your list is your array has become just distinct values. Distinct values has some bells and whistles, has the ability to perform its task in a case-sensitive fashion. It also has the ability to, like by default, it excludes null and empty values. But if I wanted to include those types of values, there are special parameters that I can include to say, hey, include the empty string values. I don't know if we have any null values in here, but this would return them if we did. Apparently we don't. So distinct is basically, it does what I call distinctifies your array output. We have Steven Dolinsky to thank for this particular feature because he mentioned it after I shared the first version of this function, and I thought it was a great idea, so I worked on it, added it. Thank you, Steven. This is also, the distinct operator is also something that's in the new version of the function coming out in a couple of weeks. All right, let's see here. Languages, what are we doing here? Okay, so the point of this example is we've seen how the match all operator allows you to extract a property from an individual property from every single element in your input array. In this case, the feature is that we're not just looking to get a property out of our country object here, but we're actually looking to harvest an array of child objects of each country. So you'll notice like each country has an array under the languages property that includes multiple items. So the ask here is to be able to harvest those child items and extract them into one single array. And that can be done again with the match all operator. It just takes a little bit of path nomenclature, a wildcard array, and that tells it to scoop up all of these items and put them into a single array. So basically, this is taken, it's gone through every single input element, every country, and for each country, it's grabbed all of the languages that you see in this child array, and it's put them together in one single array as output. And quite possibly, this is something that's got duplicates in it too. So I think we could probably apply the distinct operator here as well if we wanted to. Distinct. Let's run it again. Right now we've got 368 records. Let's see if we get fewer. We get 112 records. Okay, so we've basically extracted all of the child language elements, and then we've distinctified them and put them into one single output array. Now, I will say here, we're doing this with the match all operator for everything. This ability to sort of collect, group together child elements is not limited to the match all operator. We could have done some kind of match that targets just a handful of certain countries. Like we could have gone back to a search where we say our country name begins with A. There's got to be some of those, right? We tell it what kind of node type that comparison value is. Yeah, so we've got this query here that says, let's just get the countries that begin with the letter A and let's find their languages and collect them together. And in this case, we just get 17 records. Point being, this example that I showed you here with the match all and extracting children, it's a nice thing to be able to do, but we're not limited. The task for extracting children like that is not limited to the use of the match all function. It applies to any kind of query that you're doing.
Steve, can I ask you a quick question?
Absolutely, please.
Thank you. I noticed a capital A, and for the beginning of a country name, that makes sense, but I'm curious what case sensitivity we should expect here.
Oh, great. So the begins with and ends with are case insensitive. And I do not have a case sensitive version of those. There's a case sensitive version of the contains operator, but not a begins with and ends with. Those just are basically out of the box. They're case insensitive and not much way around that at this point.
And so all matching, not just begins with and ends with, but all matching aside from the compare will be case insensitive?
All matching aside for the, sorry, when you say all matching, you mean like any kind of matching that we're doing?
Well, like when name equals Afghanistan, for example,
okay.
if Afghanistan were all caps,
Okay,
would that matter?
Yeah, it does. So let's take Afghanistan for a second here. This is a great question. So I'm going to say, we're going to make this a little simple here, right? We're going to not be delving into like returning child objects and so forth. Let's do name matches, or I should say equals Afghanistan. And we can see right here in this record here, we see exactly what the case is like. Let's change our case around a little bit, right? This is going to be case insensitive, the equals match. So we're going to get our match. But there is an operator called exact, which I wasn't demonstrating today, but it does exist. And that is for when you want a case sensitive match, and that's going to return nothing. So you have your choice between whether you want to do a case sensitive or a case insensitive match when it comes to full equality. However, when it comes to begins with and ends with, you don't really have much of a choice. It's just case insensitive.
Thanks so much.
Yeah, I hope that was clear enough. I know I kind of, spat it out with some marginal articulation here, but hopefully the point got across.
Very clear. Thank you.
All right.
Steve, I have a question.
Absolutely.
Kevin's example of wines ordered from Alabama and using the list distinct to eliminate multiple values. Is there a way of creating a more complicated array which includes the number of occurrences of a particular value, like subregions or particular wines?
Yeah, and that will be that's going to be sort of closer to the end of this this demonstration. I've got what I consider some more advanced queries, the kind that that like you're really only going to get into if you really dig this function, or if you just, you're a glutton for punishment. It does get how can I say this? The more complex the ask is, generally the better your understanding of how this function must be in order to execute that. And sometimes it'll take 2 passes to do what you want. You'll take one pass through JSON query to get some results, and then you'll process that again and get some secondary results. So I will try to make sure we get to some examples at the end that show some stuff like that. I refer to them fondly as pizza cutter examples, because the pizza cutter as a tool, if you were just use it as a single-use tool, the only thing you could ever do would be to slice pizzas in half, and none of us would ever be able to go and get a slice of pizza. But with repeated operations of the same tool, the pizza cutter, that is, you get to slice your pizza into basically, quarters and eighths and sixths and so forth, making pizza slices available. So I think it's a great tool, but it requires multiple use, and we'll have some multiple use examples, the pizza cutter ones, at the end. But I better kind of hop to it actually, because we're only on example 13, and I won't even tell you how many we've got. So let's see what I can do here in terms of getting us through more stuff. I might skip a few examples. Let's see. We're doing data harvesting. I think this example here was just the distinct languages, which we saw a moment ago. So we can skip ahead of that. Match all with the transformation. Basically, it's the same concept. You're saying, hey, go through and harvest information from every single object, but instead of returning one value, we use the map to return hand-picked values. So I just ran this one. It took a little longer because it's working a little harder. It took almost 2 seconds, 1.7. But you can see I've chosen exactly what kind of data I want to harvest from every element. And that's what it's doing. I'm going to move forward a little bit. I'm probably going to move a little faster. Let's see here. Lists we saw Kevin demonstrate. Basically, the list operator takes what would have been a JSON array. Let's get rid of it for a second. We can see here, we're basically asking for the capital city of every country that has a sub-region equal to Eastern Asia. And it would look like that. And if we were to use the list operator, we get it as a return delimited list, which, as we know, we use so often in FileMaker, or at least historically, we've used it so often. The list operator does support being able to supply character code values to supply a custom delimiter. So if I pop that in there, we're going to get a comma delimited list. This is basically character code. 44 is the character code for a comma. We precede it with some zeros because these are in 5-digit blocks. 32 is the character code for a space, and that's why we're getting comma followed by a space. You have to remember this is right to left when we have these code sequences. I've got another one here just for fun, just to show you the possibilities. I put in the character code for like a little dog emoji and some dots. So you can basically customize your list output if you want. And without it, you're just getting a regular return delimited list. Okay, we're going to move on to aggregation. So another feature that I thought would come up a lot is the ability to scan through and say, hey, I want to know how many, or I want to know what's the total amount, or even the average amount. Again, we have Kevin to thank for this, because I was kind of on the fence about supporting all the aggregate operators, and Kevin and I talked about it, and he said, oh, I think it would be so great, if you could have, support all of the ones that we're used to, min, max, average. And so they're all here. Let's start with count. Basically, we're looking at something that says, hey, find me all countries which have a subregion which is equal to Eastern Asia, and tell me how many you found. The answer is 8 in this case. Something that I like to do sometimes when I'm working with the aggregate operators is I'll just switch back for a minute and type in something that lets me see what the results that are being aggregated would be like, just as a sanity check, and it helps illustrate it a little bit. So basically, it found these 8 countries. This nomenclature or this syntax gets you the result that there were 8 of them. In this particular case, let's do what I just said here for a minute. Let's say we were to select, again, countries with a subregion of Eastern Asia. We want to find their population value. We run it and we get these values, and we can take our sum operator and wrap it around that path there. and it'll give you the sum of those values. We could use the min operator, and it would give you the minimum. Max would also give you the maximum. Average will give you the average. And so that's basically how you use these aggregate operators. You wrap them around. It's a little strange because this is still within the quoted string, because you're supplying it as a parameter to JSON query, but you basically take the aggregate operator that you want to use and you wrap it around the result path that you otherwise would be returning. There are some rules, or there are some nuances to know about what types of values are counted and summed. Those are documented in the examples, but basically, when it comes to questions about whether or not you think an empty string or a null character should be, or a null value rather, should be counted, there's a little bit of wherewithal for sort of influencing that. And then some of it are just fixed rules that you should know if you're going to start using these functions. And again, that's documented in the, shall I say, the drier examples. The next operator here, it's basically, once we were getting into finding mins and maxes of things, it just became this sort of fun little thing that we tossed in one night that's like, hey, find me the element that has a maximum value for a particular property. So this is basically saying, find me the country that has a maximum population value out of everything in the set, or if there are multiple ones, it'll be returned as an array regardless. So we might get a one element array. If several hold the same value, we'll get several values in that array. In this case, we get China as having the maximum population. Is min value is pretty much the analogous operator for minimum values. And in this case, we've got a couple of entries here, which I checked to see what it was, and they have listed a population of 0, both of these countries. So that's the is min, is max value operators, sort of shortcuts for finding values that are mins and max. I think we're getting the fun examples. Fun examples are really fun, but seeing what the time is like, I think I may jump back to fun examples. Let's do one of them since I'm sitting on it. Then we'll cover some more sort of bread and butter material, and if there's time, come back to some of the fun examples. This fun example, basically there's a latitude longitude property inside of here. It's stored as an array. And so this particular example is saying, hey, find me all the languages which are spoken within a given latitude range. And so I've supplied my range here. I'm using the range operator. I've supplied a path that gets me to the languages, and I'm using this sort of wildcard notation that we saw when we want to extract child elements. In this case, the children are language elements, and we're just extracting a native name. So here we go. Language is spoken within this particular latitude range of -25 to -20. Those are the languages. As we've seen, we could wrap the distinct operator around this. In fact, I'm a little surprised I didn't do that. Maybe I spoke too soon when I said we could do that. It involves typing. Distinct. I think I got it. There we go. All right. Yeah, currencies used where there are many UFO sightings. I think I will just cruise through these, but I won't offer much explanation. You can just kind of see for fun. I mentioned to Kevin that these feel a little bit more like circus tricks to me. So currencies used where in countries which have UFO sightings greater than 2,600. Countries where the pound symbol is used as a currency symbol. And in this case, I'm using a map to sort of customize the output. So those are all the countries that have a currency that uses the pound symbol. Farsi names of countries that have United in the name. Average annual UFO sightings for countries above latitude 42. This is something that I wonder about every morning when I get up. I don't know about you. So there we go. That's especially since it's made up data, right? It's basically taking an average of the UFO sightings. And again, it's restricted to a particular match criteria that we supplied. Top level domains of countries within a specified population range. we got this right here. Oh, Kevin, you advised me not to use E notation, and you're right. I just, looks like I missed this. So something like that. List of all subregions. This is just a basic harvest like we saw before. Across everything, return me the subregions. List of all currencies used in Spanish-speaking countries. We're using an ISO code here to match everything that has Spanish as a language included in the array. And then we're returning the currencies for those matched countries, and we're distinctifying the array. So those are all the currencies used by the Spanish-speaking countries, at least according to this JSON input. Same sort of thing, but I've used a map to include the country name this time. So the previous output didn't have the country, and this one includes the country, courtesy of this a little bit of extra complexity here. Count of all capital cities which begin with the letter L, 12 of them. All right. We've just finished the fun examples, as I call them. Let's move on to a little bit more theoretical stuff. One of the questions that came up when this function was released was people, or one person I would say, asked on Kevin's blog. They posted a question and said, well, hey, this is great. This lets me find, the elements that I'm interested in. But my task is that I need to go back to my JSON and update these elements. How am I going to do that? Because, you're returning me the data, but that doesn't necessarily get me to a point where I can easily update the data within my source JSON. And, Kevin and I thought about that. We responded, gave some help, offered a new sort of quick function that would help out with this. And then later I got to thinking about, this is a real valid use case. You've got this input JSON. And it's not just that you want to find stuff in it, but you want to find and update particular rows, and you don't want to have to go and hunt and peck all the way through, because that's basically what we've been trying to avoid from the start of this function. So there's a new operator called path operator. And let's just see again what things look like without the path operator. Without the path operator, we're basically looking for a currency symbol, which is equal, or currencies, let's just return the currencies for right now. Return me the currencies that use the pound symbol. That's basically what this query is. So let's say we had a need, maybe we're going to go in and we found out that like the pound symbol was actually universally going to be changed to something else. So we were going to have to go in and find all the currencies in here that use the pound symbol and update it to something else, super pound or whatever it's going to be. So we need to be able to somehow target these particular currencies, and just knowing what they are doesn't really help us. So that's where the path operator comes in. And the path operator, I wrapped it around code. We could just wrap it around the currency object. The path operator returns you the JSON path to the object which would have been returned if you weren't using the path operator. So when I do this, it's basically returning me the path that I need to supply to JSON get element in order to access that particular node within this input JSON source. So once you have something like this, of course, you can write a loop that'll go through and iterate and update this JSON very efficiently, because it's done the searching for you. It's already told you where you need to go. You still have the task of going there and updating the value, but basically that's what the path is going to do. It's going to tell you the path of whatever it is that was going to be returned by whatever the path is surrounding. So originally, I think I had code in there. You'll notice if I run that again with the code in there, we get the path with the code. I'm tempted to drop one of these in the data viewer to show you that, but I think since we're short on time and I suspect you're willing to believe me for now, we'll leave it as is. Let's get into dates and support for date formats. This is another feature that that I thought would be really important. You've got data stored in JSON, strings, of course, numbers, Booleans and whatnot. But when it comes to storing dates, they're going to be stored as strings, right? And you don't necessarily know how they're going to be stored, or shall I say, you probably will know how they'll be stored for your particular JSON, but the variety of formats in which they can be stored is not necessarily small. And we'd like to have a way to search on that. So I've got an example, sort of, we're back to the Nobel example, the Nobel Awards, and I've got date values in here that are stored as a string in day, month, year format. And if we'd like to be able to search on those, just regular string matching doesn't really do it necessarily, because there could be anomalies. You don't know whether there's going to be 13/5/1902 or 13/05/1902. So if you're doing a string match against that, you may lose a value that you didn't want to lose. So the way we deal with that is we can tell JSON Query what the date format is, and it will parse those values and understand them as dates before it determines whether or not the value is a match. So let's take a look at this example and see what it's doing here. First off, I think I'll say the transformation is kind of irrelevant. I'm going to move it to the bottom. That's just so that we get some prettier looking output that's not as overwhelming as returning everything, nor as sparse as just returning one property. So let's keep our focus up here. We're basically saying supply some input JSON, look at the date property, which is right here, find dates within a range. And again, since we're using the range operator, we supply them as a return delimited list. When you supply your dates, you definitely want to use the FileMaker date function. That will allow JSON Query to be able to properly understand what date you mean. There will be no ambiguity with respect to what format you're submitting it in. And then for the value type, you supply a string which says, hey, we're looking at a date and it's in this format. And you can see I've got day, day, month, month, year, 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 year. Let's go ahead and run it. And what did we say? We were going to find basically everything between 1984 and 1988. And that's the values that you can see here. We could tighten it up a little bit just as an example. Let's do 1985, for instance. Smaller set of values. So basically, what we're talking about is a mechanism whereby you can specify the format of a date in the string in your JSON, and JSON Query will be able to do the same kind of queries that it could do for you otherwise, based on date values, whether it's ranges, greater than, less than, equals to. It's all supported. These are the various date formats that are supported. I didn't include every possible permutation. I included the ones that I thought would be the most common, and I think they pretty much speak for themselves. But we'll go through just a couple more examples. This one here is using a month name. English month names are supported. I'm thinking about how I might be able to do like localized month names and so forth, but for right now, we're starting with English. The month names are supported. You can do similar searching. It understands that February is 2, etc. Similarly, month abbreviations. In this case, we're using a day, month, year format. So I've specified day, month, year here. Month abbreviations are supported. I should mention, actually, the support for the month name and the month abbreviation, those are in the upcoming version of the function. The originally released version of the function doesn't have the smarts about those just yet. And similar for this particular feature, which is if you've got a timestamp in there, it's able to ignore everything past your date and still search on it as a date. It just ignores the timestamp part. So here's an example where I'm performing the same kind of search, returning the values, and it's basically just looking at the date portion when it does its comparison. Similar to matching on full dates, you can match on months. This is a variation of the format. You'll notice that instead of starting with date underscore, it starts with month underscore. So this is an example of where I'm saying, find me all entries in this Nobel JSON where the month is either March 3 or June 6, and it'll return those. So again, you're giving it the information it needs to understand the date format, and then it's taking it from there and saying, okay, I can find you stuff based on month if that's what you want. We use the in operator here. We could use a range, less than or equals to. Basically, all of the operators that you've seen so far are still at your disposal. Similar for year, I'm going to skip, well, we'll just run it real quick. We're basically targeting a particular year. What did we say? Greater than 2017. And the results are what we would expect. Let's move on. Oh, date aggregation. Yeah, I thought we were done with dates, but this is good to know too. You can apply the aggregate operators that you've seen. You can apply things like min and max to dates as well. So for instance, this example is taking a date and it's using the min aggregate operator, and it's being hot rodded with an extra parameter that tells you what the format of that date is. And that's enough information to allow JSON query to tell you what the minimum date is. So in this case, we're basically looking at looking for awards where the motivation property, which is where it gives a description of why it was awarded, contains the word culture, or I should say contains the string culture. And out of those, find me the minimum date, or in other words, in more human terms, find me the earliest recorded award in this JSON where the string culture was used. So let's do that. That was in 1976. We could similarly do something with max. Be interesting to see if we get a different value or not. 2006. Okay. Yeah, it looks like the second example is exactly what I did a minute ago, basically applying the max operator. Again, the idea is that dates are eligible for the min and max aggregate functions. I don't think I gave them to you for sum because it just didn't make sense to me to sum a bunch of dates, provided that you provide the format. Okay, we're getting close to the end here. I think we'll go ahead with these last few examples. Basically, the concept is just as we want to support multiple date formats, we want to support multiple number formats. And by that, I mean the decimal character may be a dot, the decimal character may be a comma. And if I were to run this example right here, it's basically looking at this fabricated field here called Twitter mentions average yearly. And you'll notice I put it in a string. And as a string, we're looking at this value down here that I've highlighted, 20.245. We don't necessarily know whether that's 20,245 or whether that's 20 and 245 thousandths. We would have to know what the intention was of the person who composed this JSON, whether they meant for the decimal character to be a dot, in which case this is 20.245, or I should say 20 and 245 thousandths, or whether the dot is actually what I would refer to as a thousandth separator, and that value is 20,245. Assuming that you know that, you can supply this information to JSON query and it'll treat things accordingly. So if I put in a dot here, we're getting, basically I should say, we're looking for where this value is greater than 2000. We get this one value. If I tell it though, that the decimal separator is a comma, what are we going to get? We're going to get a lot more values because all of these are actually things like 34,405, 8,013. So basically, similar to how you can supply a date format, you can supply a decimal character format. And with that, I think we're really close to time. So I'd like to take questions, and I apologize to the person who asked for a more complex example. Let's see. Here's maybe this one last example here we can take a look at. Matching entries based on an aggregate value. This is an example of something that requires 2 passes. And the idea here was to find me all countries which have more than 7 bordering countries. My apologies again to the person who asked for this type of stuff. This isn't exactly what you're looking for, but maybe it'll kind of give you a hint as to what is possible. If I just return the result from this first query here, I've used a map and it allows me to generate a list of, did I click it? It's a little slow, okay. A list of countries and how many countries border it. And it's doing that by counting the number of values in this border array for every country and generating this list. Once I've got that list, I can pass it in to my second call to JSON query. And that's where I'm just doing some basic matching where I'm saying, hey, of this input that looks like this, give me the ones where the border count is greater than 7. And let's run that. And it'll finish just before 11:15. There we go. That's a list of countries that have a border count greater than 15. We've used their native names, and Thank you, everybody. I appreciate your attention.
Woo!
Made it.
Well, that was amazing. Really, really great stuff. You can go ahead and stop sharing your screen if you want, Steve.
Okay. Yeah.
Whenever you are ready.
Great, thank you. And thanks for inviting me here. I haven't actually done one of these presentations before, but I'm sort of thankful for, I guess, thankful for COVID, because since a lot of these user groups have moved online, it's given me the opportunity to join them all around the world. I no longer have to, find the nearest one that's about an hour drive away and try to make it into my schedule. So I think this has been one of the very few benefits of this time. So I wanted to talk about data modeling today. I actually gave a DevCon presentation on data modeling, gosh, quite a long time ago, probably 12, 13 years ago. And I actually did include supermodels in my slide deck, but I don't think people got the connection. So unfortunately, there's no supermodels here. This is just really about sort of the evolution of how I've been thinking about data modeling. And I subtitled it, How I Learned to Stop Worrying and Love Inconsistency, because that's pretty much, I think, where the future is headed. So for anyone who doesn't know who I am, my name's Corn Walker. I am a senior intern at Proof+Geist. And I say senior intern because after 25 years of doing this, I still have quite a bit of imposter syndrome. I'm hoping that maybe with another 10 or 15 years, I can finally get rid of that. And like most people, I kind of stumbled into FileMaker. But unlike a lot of developers that I know, I actually do have degrees in math and computer science. And I actually did learn data modeling formally to get those degrees. But I'm also trying to unlearn a lot from those years, because that was 30 years ago or more. And I feel like a lot has changed, and a lot of us are still holding on to the old ways. Some more about me. I likely have undiagnosed ADHD. And as a result, I titled this like key interests, and I started filling it out. And when I got up to about 37, I said, well, maybe I should whittle this down a bit. So I whittled it down to pretty much 4 interests. The first one is software architecture. I've been very fascinated with how software is built. When I first learned computer science in university, they started us out programming in machine code. And then we graduated up to assembler. So it was, at such a low level that we never got like this 30,000 foot view of, what is actually an application, when you're actually moving bits and bytes around in registers. I'm also interested in hardware architecture. Back when I was in undergrad, I worked on a number of different systems. I got exposure to a lot of different systems. We had a PDP-11, we had a Silicon Graphics Iris Indigo, which was an incredibly powerful graphics machine, whose power, I think, is exceeded by the iPhone 4. We also had like an IBM Xterm system. And one of the other things I got interested in was I had a short internship at Cray supercomputer, and seeing the way that they developed their computers there was completely fascinating to me. I'm also interested in building architecture, both in terms of design. At one point, I thought about becoming an architect until some working architects told me to think better of it. But I'm nonetheless fascinated with how buildings are put together. What are the different parts of their structure? And I'm also interested in brain architecture. Lately, I've been thoroughly fascinated with how our brains work, how we think. Getting into Buddhism a bit, and learning about things like the default mode network were really fascinating. Learning about different brain structures, that explained both my own brain and allowed me to actually understand the brains of others. And when I started thinking about these 4 topics, I realized that they actually kind of blend into each other because they inform each other. You know, a lot of software architecture is about representing the mental models that we have about the tasks that we have to do in our everyday lives. And then our software architecture is influenced by our hardware architecture. Our hardware architecture is influenced by how we think of cognition and how the brain works, which is also impacted by building architecture and how we perceive things and how we structure things. And even our general moods are influenced by all of these different things. So I see a lot of feedback and looping through all of those different interests. So really, I think I only have a single interest. So this presentation is in 3 parts, and I simply titled the first part, The Past. And I try not to think about the past, but I'm always thinking about the past. And I wanted to start by looking backwards a bit. And I actually thought about skipping this part because I'm a terrible storyteller, according to anyone who's had to suffer through my stories. And it seemed like I might have included this just to indulge myself an opportunity to tell a story to a semi-captive audience. It's also a little bit against my Buddhist nature to live in the past rather than the present. But in this case, I think it might be useful to understand how we got here. Otherwise, I feel like I might run the risk of just showing you something that looks like a solution in search of a problem. So I started out in Resonance, which is about 3 years after I started using FileMaker semi-professionally. And Resonance was my first full-time FileMaker job. And what they did is they provided templates to schools based on the FileMaker Pro client-server architecture. And these templates were highly customized for each individual school according to their needs. And every template that we delivered built off the last one we delivered. So, you know, a school would ask for something and that would be added to the template. And then, you know, if you're the 6th or 7th school, you know, you've got a whole bunch of features that the other schools before you had requested, some of which you know, were great and some of which you're like, why is this in here? I had a past in education. I was a school teacher, as most of us at In Resonance were. But I left that career behind because being a teacher made me choose between buying diapers or buying gas, and software seemed a little bit more lucrative. So our templates at In Resonance, they started in the admissions office, and then we expanded to the registrar's office. And this precipitated a conflict around data because both offices were actually concerned about the same bits of data. They were both concerned about kids. They were both concerned about enrollment numbers. Both the admissions office and the registrar's offices cared whether they had the correct address and phone numbers for prospective or current students. And they both wanted to ensure that those enrollment numbers were correct because those enrollment numbers drove class sizes, they drove hiring, and they drove school revenue. And so as we designed the 2 systems separately, we saw the overlap, and the way that we address that is we just built duplicates of that data for each office. So the admissions office had a table of students with first name, last name, had addresses, email, phones, and the registrar's office had first name and last name and email addresses and phones, and they each had their enrollment statuses. And the way that we messaged around this was basically, you know, stuff doesn't change that much. You can send some emails around the office and that'll take care of it. You know, if there's a phone number change, send an email to everyone and they'll update their systems. And it wasn't really a problem, you know, because we had them messaging around that and we were able to explain why the solution, you know, double entry was okay. But then we became victims of our own success because the more successful we got, the more schools that adopted us, the more it became an issue for us, especially after we started adding additional products for different offices. We discovered more and more areas where the data would potentially need to be synced between offices. It created some conflicts around timing for when like imports and exports were happening. And the biggest headache by far was parents. The way that we stored parents in the system was we just had fields called like parent 1A first name and parent 1A last name. And the idea there was that, it was all pretty much flat. It was a flat table, had all the data we needed. But there were a couple of problems there. First is, which parent comes first? Maybe mom fills out the admissions application, doesn't even bother to mention dad. And we find out about dad later when we start sending out bills. What also happens when parents get divorced? So we started creating fields like parent 2. We had parent 2A, parent 2B in case the parent got remarried, which was fine. And then, in a completely hypothetical question, what happens when 2 different parents at the school have an affair, divorce their spouses, and then marry each other? I mean, it's a completely made up scenario, of course, and doesn't have any similarity to actual parents at any of our clients' schools. It's all completely coincidental. And when we thought about problems like that, it was like, oh, crap, how do we handle this? Because there are 3 kids in this school. Mom is parent 1 for 2 of them, and then she's parent 2B for 1 of them, and dad, we're just like, what in the world do we do? And Ernest Coe, who's one of my coworkers at In Residence, he's one of the co-founders, he came up with a solution, and he called it Families. And what Families did is it solved the data sync issues around address and phone numbers, and also around this parent data. It was a separate table that was shared between our admissions office and the registrar's office and the dean's office. And what it did is it just took that address information and the parent data out of those systems and gave it its own table. And it didn't belong to either system. And that mostly worked. And in about 2007, it was actually Christmas of 2006, I believe, a few of us at In Residence decided to break off and started up the Proof group. And when Proof started, we were essentially tabula rasa because we were able to take some of like the skunkworks stuff we had been working on. They're like prototypes and things, but we actually had no products because all of those products belonged to In Residence. And this was both scary insofar as, how do we create a company selling products when we actually have no products to sell? And also exciting because it gave us the ability to start fresh and to create new models without legacy considerations. Part of the issue with parents was that we had to somehow retrofit it to all of our client schools, whereas we have no client schools yet. So we got to make this all from scratch. One of the things that we did come up with, though, was the prime directive of data modeling. And that was this: if we have multiple products, the customer should never, ever have to manually sync data between our products. With other companies, yeah, sure, we might have to do that. If they have a different billing company or they have a different software for the library, of course, we're going to have to do imports and exports, and that's out of our control. But if they have Proof admissions and Proof academics, they shouldn't have to sync data between them by sending emails across to each other. So that's really what started our process of coming up with a new data model to serve as the foundation of our systems. And initially, we started by looking at places where the data was of interest to multiple offices. So then we also expanded that to look at the entire system and coming up with a universal data model that would work across all of our products, and each of the different application modules would just reference the data it needs, but the data wouldn't belong to any one application. So we started the search for how to develop a new universal data model, and we came across some books. The data model resource book. I don't know if many people are familiar with this. It's actually 3 books, each of them pretty hefty. I think the 3 of them stacked together, are about a foot tall. And the compelling thing about it is that these were data models or books about universal data models. So this solved the problem, for us at least, of how do we come up with these models? Well, it's already in the book. The other thing that was compelling about the book is that they talked about different levels of implementation for these data models. And that was really important because we're working in FileMaker. And if this was a SQL system, we'd have no problem. We can do whatever kind of joins and unions that are necessary to create the type of data model that we need. But in FileMaker, we don't really have those tools available. And so what we had to consider is how do we implement this in FileMaker in a way that is not going to cause us a ton of headache. And these books really talked about, well, there's different ways that you can do this. And then the other compelling thing is just that we didn't have to reinvent the wheel, which was a big thing. Part of the issue with reinventing the wheel is that, first you have to get everybody on board with the design of the wheel and the fact that you need a wheel. And then you have to come up with how does the wheel look? And then you have to test out the wheel. All of this stuff has already been tested. All of these models are in use in different large organizations. So the wheel was already there. We just need to figure out how do we fit it to our car. And so that was the past. All of our problems were solved when we decided to adopt the party model. So part 2 is what I call party model woes, because, this is why we can't have nice things. The first issue that we came up against with the party model is really looking at this logical model versus a physical implementation. Because since we're using FileMaker, that's the primary concern. How do we actually do this in FileMaker? Can we actually do this in FileMaker? Do we have the ability to make the joins in FileMaker that we want? And I don't know how many people are familiar with the logical model. I talk frequently about logical models versus physical models. And I see a lot of people, they nod their heads and they, as if they are in agreement, but I never really know if they truly are in agreement. The logical model is pretty much how most people represent their data on an ERD. So this is the logical party model that's from, I think, volume 3 of Silversmith's book. And this just talks about how is the data organized and related to each other. And you can see immediately, this is not a FileMaker graph. There's no way you could implement this on a FileMaker graph. There's too many paths between each other. There's 2,700 different circular loops that you can create with this implementation here. And a lot of people who are using ERDs, the first thing they see in the relationships graphs, they try to represent the ERD there. And that's not the case. The ERD is the logical model. And so we have to think about, this is the logical model that we're adopting. How do we translate this into a physical implementation? The next thing that we had to think about was data normalization. I remember probably a decade ago or so, data normalization was all the rage in the FileMaker community. And everybody's talking about, well, what normal form is your database in? And I have to admit, I was part of some of that conversation, but now I try not to talk about data normalization any longer, except to say 2 things. The first is you probably should understand data normalization, even if you're not going to follow it to the letter. And the second is that data normalization has almost 0 to do with the relationships graph. So here's the physical model that we came up with in our FileMaker solution. This is our party model in our core CRM, but this is just one way of doing it. And actually, since we merged with Geist, we've actually got 2 party models now. Because one of the fascinating things about merging with Geist Interactive with the Proof group is that we were both pretty much doing the same thing. We start looking at the overlap in the software between the 2 companies. And it was like, well, we're all doing transactions. We're all doing party model. We're all doing, it's like, well, what's the point in each of us doing this twice? Let's just make one company and do this once. But if you want to look at another implementation of the party model, you can download the Carbon framework that's available for free on the website. One of the things to note, though, is when we talk about implementation levels, this is a fairly high-level implementation, with most entities in the logical model being represented by a table. You don't have to do it this way. You could do it in just a handful of tables, but we chose to do a very high-level implementation. And then the reason that we were here is because we have multiple application models sharing a core data model. And what that means practically in FileMaker is that each application needs to have the core tables added to its relationship graph. And this is just one of the many woes that we've come against with the party model. So on the left here is our academics module, and on the right is our advancement module. And with each of these, just the core table occurrences for the party model are represented in blue. And so every time that you wanted to add the party model to a system, you had to add all of those table occurrences and all of those relationships to the relationships graph. And Lord forbid it's our academics module, because we actually have several different types of people. We have students, we have parents, we have teachers, we have advisors, we have administrators. And every time we wanted to see, an address for one of those types of people, you either have to figure out a way to connect them all, which introduces its own problems, or you have to replicate all of these table occurrences for each of those entities that you want to attach the party model to. And Lord forbid that you decided to organize your graph in Anchor Buoy, because for every single context, you're probably going to have to do this. So there are a number of woes with adding the party model to FileMaker. One of which was adding the party model to existing solutions. The actual data architecture for doing so is pretty straightforward. You just identify a subtype entity, like a contact. You add a party ID field, and then you remove any fields that are now in the core module. But again, you had to do all of that graph work to add all of that information so that you could still view all of that data. And that's where we realized that it's a lot of table occurrences to add. Actually, with FileMaker 19 and add-on modules, I was thinking, wow, this is, potentially this could be easier. We could have an add-on module that just has all of that graph in there and just add that to a solution. And, maybe that's an idea, but haven't really explored that too much. The next question is, once you've added the model to the graph, and assuming you did it correctly, which is a big assumption. I mean, we're still finding, a decade later, places where, we accidentally didn't configure that relationship correctly. The next challenge comes to updating your model. So how do you propagate all of those changes to all of the places that they're in your solutions? And the answer was erroneously, at least the first few times. And then eventually we kind of got the hang of it, but it's still a lot of work. This actually came up when I had to do a modification to the model. What we did was we added it's pretty much similar to the families concept, something called households. It's an organizational type. It was in Lynn Silverstone's party model, but we just never implemented it at first. And then we decided later that, yes, actually we did need it. And we had to update all of our application modules to represent households now, which was a big pain in the butt. But those pains are developer pains. And so, you really only feel them when you're working on this system yourself. And they're primarily self-inflicted pains up until the point that it has to be handed over to support team. And then they let you know and you feel their pain as well. But there's one other pain point, and that pain is for the user. And the issue there is performance. I'm going to go back to this graph here of our core implementation of the party model. And the thing that always stands out to me when I look at this at the start is just how long some of those relationship paths are. And when you look at the size and the depth of this table occurrence group, the one thing that's certain is that it's not going to be fast. There's no way this can be fast. And I'm sure everybody here knows the longer your relationship paths are, the slower the performance is for searches or even just displaying data on the layout. And this is just the party model here. This says nothing of the rest of your graph and relationships that have to do with your application. So this is what led to some serious soul searching on our part. The first question we asked is FileMaker even the right place to store this data? You know, we're trying to build light enterprise solutions for schools. And is FileMaker the right way to do that? And for most of our clients that only have tens of thousands of records, the answer was, you know, maybe. But then we started adding some other customers that had hundreds of thousands or millions of contact records. And the answer actually became, yeah, probably not, which led us down a few paths. The first thing we started looking at is, well, maybe we store the data elsewhere. And we looked at Drupal. We were already using Drupal for some of our online forms, our admissions applications and enrollment forms for our schools. So maybe we could move all of the data into Drupal. I believe we were using the MySQL implementation of Drupal. It was back in Drupal 5 or Drupal 6. That was an option. We looked at using ESS and doing something like SQL Server. That would have involved taking all of the party model that we created in core, extracting that, putting it into SQL Server tables, and then using ESS to add those tables back to the graphs. But then you see that we're still back at the same problem we had before. We've got these massive graphs with this relationships, and then ESS is not really the fastest way either. We looked at MongoDB, and I gotta admit, I was pretty dismissive of Mongo at the start. I was like, well, what about relational integrity? And what about this and that? And so we really didn't look at it too closely. It looked like, well, they talk about performance, but it's probably going to be a lot of headaches down the road. And then we looked at Django and Postgres, and that was actually pretty compelling for us, and still somewhat compelling for us. You know, we started creating some of our web applications using the Django framework. Django has an amazing ORM tool that makes creating most of the party model pretty straightforward. There's a little bit of complication around how relationships are implemented, but aside from that, without much custom programming at all, you can pretty much represent the party model in Django, and then you have a RESTful interface to it. So, but fortunately, we sort of got interrupted here because Proof and Geist merged. And then we started asking the question, what if it doesn't actually matter? And that brings me to data modeling's future. So there's a couple of new realities that we had to face with data modeling. The first reality is that data storage is cheap, really cheap. So just to name two, PlanetScale gives you 10 gigabytes on their free plan. So that's 10 gigabytes of data storage, or you can pay for more storage at around $1 a gigabyte. Amazon's RDS servers gives you 20 gigabytes free for a year, and they have more available. PlanetScale, I believe, is just MySQL compatible. RDS has SQL Server, Postgres, MySQL, Maria, Oracle, and others. So that's the first reality. There's no premium now to having data stored locally because it's dirt cheap to store it out in the cloud. Second reality, Our applications are moving to the cloud. Clara sees it, we see it, and I hope everyone here sees it. Gone are the days where your applications are a local desktop thing. More of our clients are saying this application has to be on the cloud. This application has to be accessible from everywhere. Of course, there are some industries and some circumstances where you have to have an on-premise database, and that makes sense. But most clients that I've run into expect to have their data available from wherever they are. And in fact, actually, next week, I am planning on just going on a road trip, just driving around. I'm not sure where I'm going to go. Talked earlier about it. Might drive down to Florida and see some people. Might decide to drive out west and see family. But I'm going to be working from the road. I'll drive 5 or 6 hours a day, work the rest of the time. And I expect to have access to all of my data just as if I was working from home. So that includes all of the apps that we use to run our company, as well as all of the data applications I'm working on for our customers. But more importantly, is that data today is distributed. And our databases are no longer a single source of truth. Now we're getting data from online shops like Square and Shopify. We might be integrating into an enterprise data system where FileMaker is just one of the many data consumers out there, and it's no longer the sole source of that data. So at least for us, yesterday's model looked sort of like this. We had our FileMaker databases at the center, and they were the single source of truth. And if we had to do some accounting stuff, we pushed some data into QuickBooks. If we had an online store or something, we pushed that data out to Stripe. If we wanted to have a website or a blog, we pushed that data out into WordPress. If we wanted to do data visualization, we pushed that data out to Tableau. But if it didn't exist in FileMaker, it might as well not have existed at all, because FileMaker was where we went to look at the single source of truth for that data. In today's world, it's a little bit different. We still have those integrations, but the data is originating from a number of different sources. So not only are you publishing your data to these sources, you're likely reading data from those sources as well. So QuickBooks Online, we're pushing customers there, but we're also getting information from there. Whenever we generate an invoice, that invoice is in QuickBooks, and we're pulling that into FileMaker. The FileMaker invoice copy is not the authoritative copy. The copy in QuickBooks is. And so using something like our Ledger Link product, what we often say is, don't replicate this stuff in your own FileMaker file. Just use the stuff in Ledger Link and let us sync between them. And it just works that way. You might get customers that are coming into your system as your first point of contact is from your online shopping cart. That data is coming into your system. Maybe some of that data lives out there. Maybe you are integrated with Facebook, and their Facebook identity is their primary data for their contact information. You might also have started implementing WordPress forms. WordPress is actually pretty amazing. I hadn't looked at it for a number of years, and then I started looking at it recently, and it can do a lot. And maybe some of that data that's in your system actually lives in WordPress. We've got integration now with things like Twilio. A lot of application interaction now is happening over SMS. It's happening over chat. It's happening over Slack, where now even your application is not the interface to your application. Now we're all dealing with APIs, and we've got other applications that are interfacing with it. And we're still doing data visualization to Tableau or R3 or other data visualization tools. But the fact is that there's no longer just one single source of truth for your data. There's actually many sources of truth, which for a person like me, who is a little bit of a control freak, not having complete control over the data gives me a little bit of data anxiety. And so I figured out the answer to this problem, which was just to stop worrying. Because I'm not going to change the market. The market's already said where it's going to go. It's apps in the cloud, it's integrations. So instead, I'm going to focus on customer experience. When we first started doing the party model, it was trying to solve a problem, which was that we had data shared across multiple offices. and that data had a way of becoming inconsistent. And the party model was the solution to that. We would just give them one place to find that data. We'd give them one place to enter that data. But while it fixed the data consistency problem that the customer had, it created another customer experience problem, which was that their applications were just slow. And if the application is too slow, if they can't find the data that they need in a timely manner, then the application doesn't work for them. So I decided that customer experience is actually all that really matters. And I'm just going to have to embrace eventual consistency. And it was only a few weeks before the Claris Engage presentation when they started talking about the new Claris product to replace FileMaker, that I was talking with Ernest about this and talking about, well, we should start looking into this idea of eventual consistency and not worrying about this. You know, start looking at caching data and just make it consistent on the back end. And then lo and behold, Claris comes out and it says, hey, next version of FileMaker, probably going to be using Mongo, and you're probably going to be having eventual consistency to deal with data model changes. So what now? How has my data modeling changed? I'm glad you asked. It actually hasn't. I still use the same party model implementation in core for data persistence. What has changed, though, is how that model is, or probably more accurately, isn't represented in other systems. Data modeling for customer experience has meant a couple of things for me. The first is I'm using JSON data transport, which has been, I don't know about you, but native JSON in FileMaker was like was a huge feature for me. It was a huge feature. I think of all the last versions, with all the features that FileMaker, that Claris has added over the past versions, probably native JSON was the biggest game changer for me, because it meant a number of different things. Just for internal operations, like I can compose and transport data objects now that match my logical model of the database rather than my physical model. It really simplifies parameter encoding for scripts, and like everything is JSON now, like absolutely everything. If I'm sending a script parameter, it's in JSON. If I'm receiving a script result, it's in JSON. If I'm doing anything with data, it's in JSON. The other thing that I started looking into was some object relational mapping. This is something that I got interested in because I was looking at the Django framework. And so when we were doing Django, we actually created a Django implementation of our core data model backed by the Postgres database. And it was really fascinating looking at how that process worked. Because all it does is it sort of abstracts the relational algebra from the user, and it handles that on the back end. You don't have to worry about that. You just come up with your objects, you come up with your attributes, you come up with your relations, and it handles all of the database in the back end. And the Django ORM was actually pretty darn good at it. Had a lot of different options, handled everything that we could throw at it pretty easily. I was pretty pleased with it. The third thing that we're doing is local caching for performance. This is really pushing the data out to the edge of the application so that instead of looking at these deep data models in the system, we're actually bringing that data all the way to, you know, as flat as possible, so that when we're looking at an application, we're looking at the data, we're at most going 1 or 2 hops on the relationships graph. Otherwise, everything is pretty flat. And then to handle eventual consistency is actually why we created SimpleQ. When we're looking at this idea of how do we actually make sure that if I make a data change here, that data change gets propagated to all of the data caches, gets propagated to all of the data objects. And we quickly came up with following the publication subscription model. And that pub sub model made a lot of sense. It led to the birth of SimpleQ, and now we're incorporating SimpleQ into Auto so that it can handle webhooks, and it's actually pretty fascinating. And I'm really excited about the way that Todd in particular has really embraced and just taken off with pub sub and SimpleQ and making that the core of part of the Auto experience. So let's see, how do I switch now? Let me share screen. So I want to finish the slideshow and just kind of show a couple of examples of how things have changed over the past. Here we go. Can everybody see my screen again? I think I'm sharing correctly. Just give me a thumbs up if that works.
Yeah, I see it.
Great. So I'm going to show a couple of different things. The first is this idea of data caching. And I'm going to choose an example. We created a system for MIT to manage their, essentially they have this thing called the corporation, and it's a little bit like a board of trustees, but expanded. There's a lot of advisors and things. And they had us build them a system a while ago. And they chose us because we had this party model that was pretty generalized and that we could use it in different areas of the system. And it led to a system where, they had to store all of the data they needed. But the thing that they found is that, the performance was a little bit wanting. So the way that this worked is we have here the UI for this system. This is the old version here that I'm showing. And if you looked at the relationship graph, which is kind of scary, all of this stuff over here in blue, this is all party model that we had. And actually some of this orange stuff is party model as well. And that's all just a minor part of this relationship graph. So if I was trying to do a search here or trying to just scroll through records, any attempt to do that was pretty poor performance. It was passable, like they didn't, come after us with pitchforks or anything, but it was a persistent concern where they said, can you address performance? Can you address performance? And I want to show you what we've done to replace that. So this is the old system. And the new system here behind it, we also did a UI revamp. If I show you the relationships graph here, the way that this works is this blue part here, this is it for the party model representation on the graph. All of that data that had been pulled out, that's all folded into this contact table. I should have hit cancel there. I apologize. I'm going to be looking at this screen for a bit. There we go. Let's go back to JSON. So I'll show you that contact table and how we're actually doing that here. So the way that we've implemented this is we actually have a number of JSON fields that store these big JSON blobs of data. So we have like JSON person, relationships, education, employment. These are all either JSON objects or JSON arrays that represent data that was stored in the core module. We also have a number of fields that are just calculations looking at those JSON fields. So if we need to display a field, we can just use a calculation for that. If we need it to be indexed, we can make that calculation stored in index so that they can do finds on it. Otherwise, it can be an unstored calculation. And really, it's all about, what makes sense for the user, has nothing to do with data, because we're just storing that all as JSON. JSON is the data store. If I were to look at like one of those data objects, I'll go over here to the contact table. Let's see if I can find JSON here. And one of the great things now is that all of these finds, because they are just on local data, like they just come up. And before this was, 2 or 3 or 4 table hops away. And so even just doing a simple find and a name could sometimes lead to a 2 or 3 second pause. And instead now, all we have is this, we have this JSON object here. I've got an array of email addresses. I've got some IDs. I've got an array of phone numbers. I've got all of this data here. And all of this data is just represented flat as calculation fields in this table. And it's a pretty simple to do. And this is actually the thing that was most attractive to me about adopting this way of modeling, is that you have to learn a little bit of JSON, but after that, it's just really bog simple. You're just adding calculation fields where you need to. There are some things like displaying arrays that are a little bit more complicated. And what we've done is we've created some custom functions to help us. For example, if we want to display emails, there's a couple of things that we can do there. One is we can, if we go back over here, let me see if I can find another record here. One of the things that we can do is we can just have a custom function that takes that data array and creates a JSON representation of it, or I'm sorry, a visual representation of it, just as like a calculation field would, and just kind of flattens that data out. The other thing that we can do is we can just extract some of the IDs out, and that's what I'm doing here for my contact methods. So I just extracted the IDs out into a list of IDs, and then I just have a simple portal over there displaying a single display field. And again, if you look at that relationships graph, you can see that each of these things is just one hop away. So if I'm looking at these contact methods, or if I'm looking at, a particular address or email or phone number, because I've got all of this data just one hop away, the performance is pretty darn good. That has led to a couple of different things though. So in this system, one of the questions is, well, how do you edit this data? Because we don't necessarily want them to just, click into a field and edit it, because first of all, those are calculation fields. So what we decided on was that really we just create edit forms for things. So this edit form is pretty slow right now, because when I was pulling Jason's info off the internet, I said, well, I'm going to grab a picture of him. And I didn't realize until about 2 minutes before the presentation started that this is actually a fairly high-res picture. But the way that this works is we've created an edit form where they can actually edit this data for JSON. And again, this can be, this is just like flat data editing, because we don't have to worry about what is the actual structure of the data on the back end. We can put this information here. It doesn't matter that the assistant here is actually a completely different party record and that there's a relationship to that person. It's just an edit form like you'd find on the web. And then we can save that information to the database, and it handles it on the back end. And I can show you what some of those scripts look like. Here we go, edit contact. So the way that we deal with these edit forms is that we have a thing that is sort of like a forms utility. It's a number of layouts and scripts and everything to define what the form looks like. And we basically send it a JSON package. We grab the data for the form in this step here. This is just JSON set element. I'm grabbing all the data. Now I could have looked at the JSON fields themselves, but because this form is for very specific editing, I just decided to look at some of the calculation fields instead. So we create a JSON object with this form data. And then we call the form API to actually display the form for editing here. And I have that up here. And what the form API does is it creates a record in this table. These fields are just generic fields. And it populates those fields with the form data to be edited. Once all of that's done and we click save, all of this form data gets packaged back up as JSON and returned here. And then we push this JSON back to the database. So the first thing that we do is we take this JSON object here in the JSON person, and we just overwrite the elements in that object with what was returned from the form. I have this second step in here, which was for when I was debugging this, but I don't need this anymore. All of those fields on the layout are actually auto enter calculation fields. And I set up those auto enter calculations so that if my JSON got munged for some reason, that the data would still be there, so that the user doesn't just see a whole bunch of JSON error messages for all of their field data. But this was sort of a, during development, sort of belt and suspenders approach, where I'm modifying the form JSON and then I'm setting the fields anyway, just in case. But I'm actually going to remove this pretty soon. And then the next step that this triggers is it actually sends a SimpleQ message, and it tells SimpleQ, hey, this record has been updated. Here is the party ID. Here's all the data. Go ahead and update the core data model with this new information, which in turn kicks off the SimpleQ message to all of the subscribers that have caches of that data, say, hey, this data has been updated. You should get the latest data. There's a couple of different ways that we can build this, this JSON here. The way that we're doing now is we're actually using the execute data API script step. And that's over here. I'll show you, it's in my core API. Here we go. So what we have is we have a number of layouts that are representing the different objects in the system. So these are sort of the things that we have defined as objects in the system. They're not all of the tables that are part of core, because again, all of those tables aren't actually meaningful. A whole bunch of them are join tables, or they're type tables, or things that don't really matter. You know, from the person perspective, what we want is all of the fields that have to do with the person, regardless of what tables those are in. So one method we do is we use execute data API to actually get this information on this layout and package it up as a JSON object. And I don't know if anybody knows this, particularly with relationships, we have, because again, we're using a universal data model, one of the things that happens is that all the emails and phone numbers are sort of stored in a similar table, and it's called contact method. And all I've done here is I've added a filter to this portal to say, hey, is this an email record versus, you know, or is this a phone record? So those filters make sure that for each of these portals, I only see email records for one portal, phone records for the other portal. Otherwise, it would show all of the records intermingled. And then the other thing you can do is if you rename the object that the portal is based on, email, when you do the execute data API, it will use this object as the portal name in your portal data section rather than using the name of the related table, because again, this related table appears twice. And I haven't checked this recently, but I know in early versions, FileMaker would actually generate invalid XML data because of that, or JSON data rather, because they would have two different JSON arrays named contact method in this case. But that's been pretty helpful to be able to have those names automatically renamed here. And that also means that, you know, this contact method table is a join table. I don't have to have the object named whatever my table name is. I can have the object named something that's more meaningful to me. And then we do the same thing with some of the other things. So these are like the preferred phone number and the preferred address. And it's a single portal, but by doing it this way, we can set these things up as a single object array rather than having it be just a bunch of fields on the layout. That's made a lot more sense for us, especially because, again, a lot of these fields have the same names, and so it's hard to disambiguate between them. I'm going to open up my debugger and my data viewer. So what's actually going on here when I run get person, there we go. And again, I'm a big fan of abstraction. So you're going to see that there's a whole lot of scripts involved here. And that's just because I don't like to repeat myself. So when I'm running through a script, and if there's multiple steps that are the same among multiple steps or among multiple scripts, I'll just repeat those. Or instead of repeating those, I'll abstract them to another script. So that's this section here, which is the abstract get method. This is just handling the execute JSON or execute data API part of this. So the script is actually going to set the query parameters based on this layout. It's going to call an abstract method. And this is where I'm going to set my breakpoint to actually get that information back. So I'm going to call that here. Let's see, how do I get rid of that there? So I set up my DAPI query. Again, I've abstracted the getting the DAPI result from this. And then I'm going to return with that DAPI object. And let's see if I add this. It's a new computer. I don't have any of my watch expressions on here. So this is the standard, the message format that the data API returns. It returns an array of messages, which are your error codes, and then it returns your response. So you're going to have your field data in here, which is, so the data array. So if you have multiple records that that's part of the response, it's going to be an array. Each of these is an array of objects with an array with field data as your first object. These are all the fields that are placed directly on the layout. And then there's the portal data. And that's where you have like your array of email addresses. I've got an empty array here because this record has no relationships. You've got your array of phone numbers. And then it's some metadata about the portals on that layout. And then you have some metadata about the records that were returned. So that's the response format that the data API gives us. I didn't really like it so much. So what I do is I actually transform that. So the thing that I do is I flatten this data API response. And all that is doing is that's taking everything that's part of that response that's in the portal data section, and it's putting it in the actual data section. And that's, I think, a custom function that one of my coworkers, Brian, wrote. And so now if I look at that, let's see, that's all current. That's here. So I still have a similar format, but now instead inside of data, I have my email array is inside of there, and I've gotten rid of the portal section. I think this is a little bit saner, especially because this is going to match more how we store the data locally in those fields. The next thing that we do is something I haven't really talked about. I talked about how I liked the ORM in Django. And one of the things I thought about was like, well, I don't really like the FileMaker field names that I created. Or I don't like the fact that all of these things are prefixed. If you look at this here, some of this data is in the record and some of it's from a related table. And FileMaker will put that table prefix on there. And I don't really like that. I don't like the fact that when I'm looking at this phone, some of it's from contact method, some of it's from phone, some of it is metadata. And so what I decided is that I'm going to create my own object model, very much like I would do in Django. And I'm going to apply that to this flattened response that I got back from here. And I'm not going to step through it because it actually is going to take a little bit of time to do so. But I'll show you how that's actually set up when I go through here. So what I have here is a set of transformations that will take the data for that object and will rename all of the elements. And it can do other transformations as well. Let's see if that's done. Yes. So what that is that's over here. Let's see, window. Oh, here we go. It's a set of tables that I came up with. And this is called my own object relational mapping that I've set up here. And so with my person object, what I've got is a number of attributes that I've defined. So email is an object, ID is an attribute. So I've got all of these things set up here. I've got age as an attribute, birthplace, citizenship, etc. This is my description of each of these attributes and this objects that I've created. And I've got all of my objects for my core model over here on the left. So if I want to look at what is an email has an ID, it's got some metadata about it, and it's got like a domain, an email address. Is it active? Is it preferred? What type of email is it? Is it home or work or etc.? And then for each of these addresses, or each of these attributes rather, they can have multiple different sources. So when I look at this particular attribute, date of birth, this is where I'm looking at actually doing my transformation. So this is for my person object. I've got this attribute, date of birth, and FileMaker stores its dates internally as a number. It transforms that into text when you're looking at it on a layout, which is fine, but depending on system formats, sometimes that text back to date doesn't work so well. If I've created the system in the US and it's being used in the European or an Asian country, just relying on the text representation of the date might not actually be so good. So, and this was before something that Todd figured out that actually I think is quite brilliant. What I decided was, well, I just want to use that number representation of the date, and I'm going to store that instead. And that's because JSON doesn't have a date type, but it does have a number type. And so I'm going to store it as a number. And so this is a transformation that I do on that value. When I'm reading the date of birth, I do a get as number on that. And then I also have a little section here where if that value is empty, it's going to set the type as JSON null. Otherwise, it's going to do a JSON number. So this part here, date of birth, this is the field name that it's looking at. There are some attributes that might actually come from multiple different places, depending on how you get that attribute. Because it's all based on the relationships graph and scraping a layout using the execute data API function. Sometimes when you're actually scraping that layout or when you're actually executing that, you can end up with the field names prefixed differently. And so for each of these attributes, I have the ability, like with phone, for example, to say that this might be multiple sources. So the field might be just called carrier, or it might be called phone : carrier, or it might be called preferred phone carrier, or it might have no prefix at all. And this is the way of handling that so that whenever I'm doing my transformation, I can have different formats that's coming back to me from execute data API, and I transform it into the correct attribute name, which is up here. And then I also can transform the value if necessary. So I think this is kind of overkill, but that's sort of where I like to go. We might actually take a step back from this. I don't know. This is what we're using at least one client right now. And it's a way that we've sort of managed the creation of these objects, because this way we can put this ORM table in here. We've got the scripts. All we have to do is do some layout work to set up these objects. And then we have the JSON in what's a fairly readable form as far as JSON goes. You know, this is what you get. You don't get all of the different like relationship stuff that FileMaker is giving you from field names and table names. What you get instead is actual attributes that seem to make sense. They have names that make sense. And it's pretty reasonable. We also take a lot of that metadata stuff. We just put that into its own object so that you can ignore, you can pull out, you can display or whatever. And that just kind of sets it apart. Like you can see that this is just metadata about the record. This is not actually record attributes here. I don't know, I might be crazy doing all of this, but it's been interesting going down this path and actually proving it out by actually implementing it at a client and just seeing like how moving all of this data, flattening the data, sort of getting back to that original point. You know, I look back at when I was within Resonance, what we did in the beginning, and what we talked about was, you know, those tables, they were flat, the data was duplicated, but the one problem that the customers didn't have, they didn't say it was slow. Flat data is pretty fast. And so now the new prime directive for data modeling at Proof+Geist is not don't ever repeat yourself, but rather performance matters. And to the extent that your model hinders performance, it's not a model issue, it's a customer experience issue. And the customer experience is the only thing that we're really focusing on now. We've developed the tools in the back end with SimpleQ, with some of this object relationship mapping stuff, and also with abstracting the forms to make it a bit easier to edit this data. All of those things were in service of getting back to the user so that they can have a data model that actually makes sense to them. When they look at fields in there, they can actually do exports now. those exports make sense. They didn't before. Exporting out of the system was a nightmare. It was something that they actually had to ask us to do, to set it up for them. Now they can just go file, records export, and the field names are field names that they recognize. All of the data is in the table where it makes sense. Where it doesn't make sense, or if the data is a little bit farther away, it's at most 1 or 2 hops away now. There's no longer like having to traverse these huge relationship graphs and not understanding where their data is actually located. And all of that, I think, has been the biggest benefit to changing our approach from data modeling, from caring very deeply about, is this the correct relational data model that's doing the correct relational algebra, and getting away from that and going to what's going to serve the user, use document data models that are cached at the application, that are flat, that have the user performance that we expect. And frankly, we can deal with the consistency issue on the back end. We've got SimpleQ now. So all of that stuff can be pushed out. There's going to be problems, of course, maybe a user is camping out on a record that's locked somewhere, but you've already had that problem. You've had that problem from the beginning, regardless of what your data model is. If you let users camp out on records, then they're going to lock records. So you're not going to be able to update them. But by abstracting updating to a form, which is just another table that has the data represented there, we've kind of solved that too, because users aren't doing direct editing. And so we don't have to worry so much that a user's camped out and locking a record that otherwise we need to update. So I don't know. I'm looking forward to feedback, especially if it's like, man, you're crazy. This doesn't make any sense. Why are you going through all that work? That's really appreciated, because I need that check to make sure that I'm not going off the rails here.
Warren, Lynn Allen here. I'm thinking everything old is new again. It was back in FileMaker 3. Frank showed me an interface where he had everything put into globals for editing. He'd go to a special editing screen, transfer all the existing data, and then he could do checks, against changes and everything. That was 17 years ago. But and we've all encountered those points where normalization just does not work in FileMaker. As you say, it's the performance issue. So the fact that you've developed all these tools and moved it into the fastest available technology with the JSON. I personally would like to see a little bit more of your JSON objects and your calculations that extract them, but that might be another presentation.
Yeah, and I think we're going to be releasing some of these tools, most of them for free. SimpleQ is going to be released for free. I know we're still kind of doing some internal work on it. The form editing stuff, I think we're going to also release for free. It's just a simple set of scripts and some setup, so that you can easily with JSON map, and create any form editor that you want with it.
Cool. Well, keep us all informed, obviously.
So, Corn, you said you have this. Basically, you're using this in one project for one live client right now, right?
Correct.
And is this a deployed solution at this point, or is it still in development?
Oh no, both. It's deployed, so it's actually working at that client. There's just refinement of things here and there. For example, when doing the transform, sometimes if the transform is particularly complicated, or if there's just a lot of data in that JSON, a window will show up saying, loading the transforms. Getting rid of things like that, finding those little edge cases and focusing on performance there.
Mm-hmm. The idea of clicking a button to get an edit interface, otherwise viewing your data as read only. Have you gotten any pushback from the client on that, on having to take that extra action in order to be able to edit anything versus just being able to drop into a field anytime and make a change?
Well, one, no, because it's faster. You know, I'm actually connecting over a VPN to a development server, and it's actually, you know, when they're actually on site, it actually works pretty darn fast. But also, we had the benefit of pretty much 100% office turnover between the old project and the new project. And so the new employees didn't know any different. So that was really a big boost for us, where we didn't have to worry about addressing that issue. It's just the way that it had to, you know, that it worked. And again, because it was fast, they didn't care.
Yeah, I can see where switching somebody over to this, if they were familiar with old school FileMaker solutions, they, you know, you might get a little bit different kind of. Yeah, I think to implement something like this, you have to be careful about what project you choose it for.
Yeah.
You know, I'm not saying that it's not something that you could go 100% with in the future. I think that you know, you have to get people past old ideas and old ways of doing things. The fact
Right.
that, like, as you mentioned, that that's something that you'd find commonly on a web form helps a lot.
Right.
You know, the web helps us in some ways and hurts us in others, right? When it comes to what people expect from the UI.
Yeah. The other thing is that's not actually necessary. There's different ways to build your JSON. Like you could have flat fields, have your JSON field instead be a calculation, and you could just edit the fields right on the layout. We did it to address the potential record locking issues, because you know, people leave for lunch and they're camped out in a record, or worse, in the portal of records. You know.
Yeah.
So it was really to address record locking, to make the form editing fairly simple for them, and it killed both of those birds. But you don't need to use that part, just like you don't need to use the ORM transformation part. All of this can be done. It's just like there were all these different pieces that made it easier for us, or simpler for us to, once we put them all together, it solved more problems than it created.
Sure. It's really, really impressive, I think. You know, it's a big change from the paradigm that we're all used to. Obviously, or a whole set of paradigms that we're all used to. But anybody else have any questions for Corn on this?
Yeah, I have a few questions. Jason here. I just want to understand a little bit better about how much you've abstracted in that form editor. So all the fields are generic, but are there different field types? You have number fields and date fields.
Here, let me show you that. If I can find that here.
And you're creating a new layout for each form, though, right?
I'm sorry, say that again.
And for each form, you're creating a new layout. Is that right?
Yeah, for each form type, it is represented by a layout. Okay. So, like, these are some of the form types that we have here. I've got new contact, minimal, edit contact minimal.
Are you sharing?
Oh, sorry. I forgot I stopped sharing. Let's find that again. Here we go. Share. There we go. Sorry about that. Yeah, so we set up all of these different form types, and excuse me. And for the form that I showed, this is essentially the JSON that we config. So we set up, this is actually just one field with a number of different repetitions. Don't tell anybody that I'm using repeating fields. Actually, that's one of the other things that I've come to love, because they're just arrays. You call it an array and everybody loves it. So we set up these repetitions here. We give it a field label. We can give it tooltips, placeholder text, whether it's required or not, helper text. We can put expressions on here to transform the data. We can put expressions here to validate the data. We say what the JSON key is, where we get that field data from. And then when you're building an actual form, let's see here, like this one here. All you're doing is you're just putting these fields onto your layout and specifying which repetition. Now, generally speaking, we started out looking at different data types. We thought about, well, do we want to have a date type or a timestamp type or a this or that type? And you don't really need to. It depends on whether you want to use FileMaker's internal field typing validation to have sort of that strong typing or not, or if you want to handle that with validation that happens when you validate the form. So you can see here that I do have a calendar widget here, but this is just a repetition on my text field.
And so how did you do can you do a calendar widget on or is that like a JavaScript thing or something?
I'm sorry?
How do you do the calendar widget on a text field?
How do you do a calendar widget on a text field? That's a good question. You cheat, I think, is the answer. What we have, I don't have it in this file, is I have actually a palette because we have our own theme that we're using for this. I don't know if we've released that or not either. If we haven't released it, we'll release it eventually. So we have a theme, and what we have is a palette where we can drag objects off of that palette that are themed correctly. So like for data entry forms, I have a palette that has all of the fields on there. And so when you copy it over or drag it over, because it's not the same table, it doesn't know what that field is, and you just repoint that field to the correct field, it still keeps the formatting. So if you had a calendar widget on there, but you point it to a text field, it still keeps the calendar widget.
Okay.
So it's cheating, I guess, but.
We got a couple people with hands up here. Bev, you're first, and then Christopher.
Yeah, I just wanted to verify that I heard what you said, Corn. If you name a portal in the inspector, that is used when you actually do the execute FileMaker Data API, rather than the TO name of that portal?
That's correct.
Okay, good. I thought I heard it right. I wanted to verify. Thank you.
All right, Chris?
Yeah, so really, really cool stuff. I'm actually working with you guys with one of my clients. I don't know if you're aware of that or not. So I'm learning the Proof+Geist ways of doing things. So one of the questions I have is, I really like the idea of performance, very much so. I'm getting a whole lot of new ideas I need to pitch. One of my concerns is when one type of record is displaying data from another entity type. So in this instance, I'm thinking an account and a facility. And let's say something about the facility is updated, but is often displayed in the account. And for performance reasons, you could, flatten that. But my thought was, in our particular instance, modification timestamps are a really big deal. And so it seems to me that tell me if this makes sense, is that rather than have your standard method of doing a modification timestamp, maybe build in a way to disable the timestamp from triggering if you're pushing data from a different entity into the account record, because like the account record itself isn't actually changing, the facility is. Does that make sense? Right. Is that something that you've come across or addressed?
So I mentioned in one of my slides, and I probably should have talked about this more, is when I asked the question, what have I changed about my data modeling? And I said, I haven't. That's because behind all of this, when we're looking at, where is it? Let's see if I still have this file. When we're looking at this that gets transformed into JSON, this is still the same old core model that I had. This is the same party model. None of the tables have changed. It's all still there. So when we're updating a record, so if I'm updating the person record, even though in my application, everything's been flattened, if I'm making a person update, only that person record gets updated, and then only that timestamp for that person record gets changed. So I wouldn't be updating other records that didn't get updated for some reason. And the other question there is, you know, in terms of how we use timestamps, I've always had a problem with last modification name and last modification timestamp because they don't actually tell me anything. They don't give me the forensics I need. I know when I was dealing with schools more closely, frequently data would get munged, and then people would be looking for who to blame. And they'd go looking for that last modify timestamp and that last modify name. But that doesn't tell you who actually messed up the data. That just tells you who last touched the record.
Well, in
and
our
so I found,
oh, sorry.
Go ahead. Oh, I just found that less useful than logging.
I totally agree. And in our instance, we do have change logging. So
yes.
But we also use the timestamps for syncing data to an offsite storage. So like in order to determine which records get pushed, they use the timestamp. So that's,
okay.
Yeah.
So that's why we have SimpleQ. And I didn't talk about this because it wasn't really relevant to this. All of that stuff now is handled through SimpleQ for us. And it's handled real time. So if I modify, you know, I'm no longer doing, at least with this client and probably going forward in all of our, the way that we're going to be looking at how we model data and how we update data to other systems, using SimpleQ. And I don't remember, I think we might have put a little, like a part of the SimpleQ engine into this solution that you're working on, but we didn't put SimpleQ itself in there. But the idea is if I make a change, I can push that change out to update other systems right when that change is made. And because that's handled asynchronously, I don't actually worry about that.
Great, thank you.
Really interesting stuff, Corn. Really makes you think quite a bit. Just my brain's kind of spinning between these two presentations together. My mind's blown. It's been really interesting, and thank you very much for presenting this. Really appreciate it. And Stephen and Kevin also, great stuff. Really interesting what you do with JSON Query, and you know, there might even be some crossover between these two things for some of us. So really cool. Thank you all for being here, and we'll see you all next month.
Thank you all. Thank you.
Thank you.
Thank you. That was fantastic.
Awesome.
Great stuff. Bye all.
Bye.
Bye.
Bye-bye.
Bye, everyone.